So the formal charge on this oxygen, it has 6. That's where it is on the periodic chart, that 6 tall column over. And what's actually attached to it is we've got 1, 2, 3, 4, 5, 6, 7. So 6 minus 7 gives us our -1 there. And then our xenon has, well, it starts with 8 because it's a noble gas. And then it has attached 1, 2, 3, 4, 5, 6, 7. So this one is +1. So that's a plus, and that's a minus. And if you want to double check your chlorines, there's 7. And then they have a total of 1, 2, 3, 4, 5, 6, 7. So they're 0. So they're good to go. So the question is, can we fix this oxygen and this xenon? And you may be kind of seeing what you can do right here is, like the question is, what if one of these were actually xenons? So if we go ahead and change it. Again, I'm not losing electrons. I'm just kind of redesignating which electrons came from which atom in a way. So now we've got a double bond right there. And now our electron count is that oxygen has 6. So that gives us a value of 0 over here. And then so we can get rid of that. And then our xenon, remember he was 8. But now we can subtract out 8. And that's going to make xenon 0. So now the entire structure is full of 0 formal charges. Here's the next one. Zoom in a little. So in this case, phosphorus he came with a total of 5. And by the way, the oxygens, they came with 6. And then if I'm trying to subtract out my phosphorus, 1, 2, 3, 4. So that makes this +1. So this would have like a plus. And then our oxygen, 1, 2, 3, 4, 5, 6, 7. So that's a -1, so that would be a minus. Now, that's true for all of these oxygens. And you'll notice that our oxygens, we have 4 of them, so that's 4 minus plus 1 plus does give us that charge over there. So we would expect some probably negatives in there because we've got a charge on the whole molecule. So how can we fix it? Well, again, these oxygens, these pesky oxygens. Because phosphorus, and I should have said this about the xenon also, because the xenon count total around it, like if you were to actually count the electrons around it, this has a total of 2, 4, 6, 8, 10, 12, 14, right? 2, 4, 6, 8, 10, 12, 14. This gives it 14 electrons. It's supposed to have 8. But the reason that we can change the structure like this is because it's the third row or below. It can basically expand its octet, or you can say that it has a hypervalent octet. Those crazy words. It just means that they're so big that you can squeeze a few little electrons in there, and it's not really going to care. So we're not saying that it doesn't have a lot of electrons on him. Remember, formal charge is just like this counting mechanism that we use. And then over here for this one, we have our phosphorus, and what we're trying to do is fix it. So we're just going to grab these 2 electrons right here. So we're just redesignating which electrons came from which atom, not adding electrons or losing electrons. And that's going to make it so that now we have 5. So this is going to be 0, so I can erase that charge. And then up here, this is going to be, now I'm down to 6. And so that gives me 0. So I still have some that have negatives, but my central atom is now down to 0. And if I try to mess with it anymore, I'm just going to make that central atom start going negative. So once you get it to 0, you probably want to leave it. And again, that does give phosphorus more than 8 around it. We've got 2, 4, 6, 8, 10. That means that phosphorus has 10 total electrons around it, which, again, it's supposed to have 8, but because it's a third row or below, it can do more than 8. Remember, formal charge isn't counting the total number of electrons. All it is it's kind of labeling some electrons as coming from phosphorus and some as coming from oxygen. And the way we do it, it just helps us know that we probably are going to get the right structure. And this is how it turns out. Yes, it is going to have resonance, which is super cool. And you might not have noticed that it was going to have resonance the first time you worked it through. So if you had chosen this oxygen for your double bond, or this one, or any of them, that's fine. Just make sure you only had one double bond in there. And in fact, the actual picture for this molecule would have a total of 4 options with arrows between them, where the double bond is placed in all the different oxygen positions.